Here's my interview with two of the leaders of the Genie 3 team. Genie 3 came out just a couple weeks ago, and it is an incredible text to fully 3D controllable world. And it is highly accurate and has so much potential for video games, agent training, world simulation, and so much more. So in my interview, we talk about what went into training Genie 3, what their plans are, the future of world models, and of course, we talk about simulation theory. Here's the interview. All right, so thank you, Jack Shlomi, for joining me. Jack Parker Holder is a research scientist at DeepMind. Shlomi Furcher, am I saying that correctly?
Yeah, close.
Okay, research director at DeepMind. Thank you guys so much for joining me. I'm really excited to talk about Genie today.
Awesome, thanks for having us.
Yeah, absolutely. So, okay, when I first saw Genie, I was pretty blown away. I've never really seen fully controllable text to world models before. First is, what is the long-term goal for Genie? Is it more of a research tool for agents? Is it for creators? Is it for general simulations? Like, what is your overarching goal?
Yeah, so the way I'm thinking about it is the capability to generate the world just from text. It's kind of like a fundamental capability that can be used for many things, basically everything that you've mentioned. In a way, if we can create a realistic world that is, you can interact with and you can walk around, and maybe it simulates all of the physical phenomena that we have in our own world, then based on that, you can use it for training agents, for reasoning about what might happen if an agent takes an action in the world, for entertainment, very long list of applications. So basically the answer is pretty much everything you can think about.
Yeah, okay, all of the above. Is that when you first started this, the Genie family of models, was that the intention, or was it more of just, hey, let's explore this research area and see what's possible?
Yeah, so I'd say when Genie models research first started, roughly 3 years ago, it was very much focused on the AGI and agent-centric angle. So a few of us had been working on like automatic curriculum learning for agents with reinforcement learning. So agents that can learn from their own experience in simulation. And we basically been trying to find different environments where we could generate diverse range of different kind of worlds and tasks, typically procedure generated worlds, right? And we basically got to the point where we couldn't really design or like hand code an environment that was rich enough that you could basically, even if you sold everything in it, it would get an agent that was able to transfer and do diverse things in the real world. And so there were multiple different paths to try and do this. One was maybe to keep building richer simulations. One was to maybe start using real video games because they can be quite realistic. Yeah. But at the time, sort of language models had really emerged as something that were becoming quite useful and quite effective. Text-to-image models were just starting to be pretty good, and so it kind of seemed like it would take a bit longer. But like maybe if we could do full world generation, that would basically solve the environment problem for agents, and then we would get like much richer agents than we would do any other way. So it actually seemed like the fastest way to get general agents was to not work on them, but to work on the environment model first. So that was the original motivation. I think it's not the case that interest has gone away. I've become increasingly convinced, and as a team, I think we're all pretty convinced that this is like a really exciting direction. But it's just sometimes when you pursue interesting research, you don't know necessarily what it's going to be used for, right? And there's been a bunch of other things that have emerged. Like I wasn't as in the know with sort of the interactive human like use cases, but those have become like pretty obviously the case in the last year or so, right? So, and actually even with Genie 3, there's been a bunch of use cases that we weren't even really thinking about that people have asked us about that sound pretty exciting as well. So I think it's one of those ones when you do something new, you often get some unintended consequences that could even be more interesting than your original intent.
So my understanding is to scale up to reach AGI, we need some kind of reinforcement learning feedback loop that doesn't have maybe a human in the loop limiter to it. And that's really where Genie 3 and the Genie family of models comes into play. It generates these environments. Agents can go into the environments and explore and learn. What kind of signals is the environment giving to the agent? Because, forgive my lack of understanding here, but the output is still maybe a black box, or how it's generated as a black box. So what kind of signals is the agent actually able to retrieve from these worlds?
So today, basically we're operating only in the visual domain, right? So the output of the world model is just the pixels observations, right? So the focus on visual outputs was just out of because there is a lot of progress in this space, right? We see video models that really made a lot of progress in realism. So we have models such as Veo and others that are able to take text and just output something that looks very realistic. And we thought that we can push on what's possible in terms of the ability to actually walk into a video and actually explore what's the world that's generated, right? So I think this is still a limitation when it comes to maybe training agents, but we can go pretty far just by using visuals. Because, for example, by looking at the world, we can know if how fast something's moving. We can an agent can understand if it has to maybe get from one point to another, what are the obstacles in its way. So even without more physical responses that you might expect for robots, we can still do a lot, start exploring the capabilities of such environments, and we're very excited about that as the first modality from many that can be simulated in a realistic way.
Okay, and just to clarify, agents, when they are training within the environment of a Genie 3 world, they are simply looking at it. It's through the pixels presented to what we would see on the screen.
Yeah, maybe to clarify a little bit. So I think right now we are posing Genie 3 as one of the potential application is to train agents in it, right? This is something we're just starting to explore, and we built on a very long line of work by DeepMind and others that used simulations to train agents, right? So we can, starting from StarCraft and Go and AlphaGo, and then basically using some game simulation or environment to train an agent to solve the game, right? And that's the initial one of the seeds that led to investments in simulation for Google DeepMind. And now we're trying to build simulations that can, you said before, taking the removing a human in the loop, but I think it's more about removing the need to actually go out into the real world to train an agent, right? Because it's very expensive to deploy, for example, a robot in some in a factory, right? Let's say that you want to train a robot to handle a new environment that it was never able to explore. One way is just to put it in this environment and it will make mistakes, right? But maybe it will be much cheaper and much more safer if it can still first experiment, learn in this simulated environment before it gets deployed into the real environment. So that's in a nutshell what we're having in mind.
Okay, and Jack, you mentioned you were a bit surprised at the use case of the human interaction, right? First of all, are you guys gamers? Do you play video games?
I used to play a lot of strategy games actually in the past. My background is mostly in programming 3D engines. That's where. So it was mostly a hobby to develop the games, but today I'm less of a gamer. Yeah.
Okay.
Yeah, as a kid, I played a lot of that, especially the driving games. But honestly, it's been quite a while. So and I guess this is quite different to gaming, right? It's kind of a new type of thing. It's interactive world generation, rather than there being a hours long. I remember playing games for hours, right, and exploring all of the side quests and all these other things. And clearly, our models can't do that. So it's not obviously a drop in for those things. But I think it's surprising that how kind of fun and engaging it is to play with it already. And I think we've seen that reaction from quite a lot of people, that they just have fun interacting with it. And that, obviously, when you're so focused on the work, it's hard to understand how much someone else who doesn't get the context, if they get put it in their hands, how compelling they'll find it. And we have had like pretty nice feedback. People do find it quite like interesting to play with. So I think that's actually something quite exciting as well. But yeah,
and Jack, I mean, it's not a drop-in replacement for video games today, right? So let's say, you know, a standard video game, 20 hours of gameplay, lots of different levels, a lot of rules, not just an open world typically, but there is at least, you're starting to see hints, especially with Genie, where it could eventually evolve into that. It could grow into that. Is there kind of a clear path yet to getting to a point where it's going to maybe not replace, but supplement traditional games? And is that something that you're excited about?
yeah. So I think on this one, like, I wouldn't say we're really considering it as a path to replace games. It's in terms of being an additional tool for kind of prototyping things. I think that's kind of where it's already at, right? Like, so I think if you're someone who's like, oh, imagine if I could, you know, what were some of the examples? I could be an origami lizard with a kind of platformer style. Then instead of spending some time to create that, you can have it in 10 seconds, you know. And like, that's pretty cool, right? Because you can immediately see things. We had someone in our like initial cohort of testers, Julian Zagalius, who I think is far more of an expert to me on AI and gaming. And he wrote a really nice blog post, and he said, like, from his time playing with it, and he had a great time afternoon playing with it, is it's kind of already there for prototyping. Like, you have an idea of a random thing that like you maybe wouldn't want to invest much time in, and straight away you can try and interact with it. Now, I think to really like narrow it down almost to being sort of looking at existing games and think it's trying to target it towards that, I think it's like maybe one path. Like, but for us, I think we're most interested in the more general capabilities of the model, and there's quite a few new things that we can try and do with it, I think.
Yeah, I'll just add that, you know, we simulating games, or like specifically, requires much more than Genie is capable today. I think if you look at the game, as you said, there is logic, there is maybe a plot, there is some. So what we have today is basically a word simulator that can take text and just let you walk around and interact with the environment, right? It's definitely potentially a component that can later on be used to build various experiences, right? It can be a game, it can be maybe exploring some, you know, in an educational setting. So I think at this point it's still very early to know exactly how people will be using it. And we actually have some collaborations with you know, in the entertainment space with various companies, and we're exploring that, and also hearing from researchers, as Jack mentioned, that give us some kind of like a feedback of what they think such systems can be useful for. I think for specifically for simulating maybe environments that are engaging, I think there is a lot of like space to explore how we can use those systems for that. For example, for making it more interesting as you walk around, but I think the key is that we can use it already for things that you cannot achieve it in any other way. And for me, this is the most exciting thing, not just to try and do something that's already existing, right? But creating in a way a new media, a new experience. For example, something that is not exactly a film and it's not exactly a game. It's something that you can maybe do only using generative models.
That's a slightly better way of saying what I was hoping to get at. So I'm glad. That's why it's good to have two of us. Everything that Stromy just said also applies to agents as well, right? Because what you were basically saying before is actually kind of a similar question. It's like, what's the goal of the agents? Like, what's the feedback they get? Like, is there any sort of like progression metric or these kind of things? It's kind of similar to what a human might want as well. And then also the richness of the worlds as a limitation right now, the richness of the worlds for humans is also a critical thing, that if we want agents to learn about human interaction and these kind of things in the model, then that's another area that we need to improve. So I think the nice thing is, by building this new thing, we actually make it more interesting for these use cases, but I don't think we're like targeting one. Like, we're kind of trying to just build the new thing.
Yeah. And Shlomi, as you were explaining it, I realized I kind of fell into the trap that a lot of people do when a new technology comes about. They try to fit it within kind of the framework of an existing piece of technology. So, when the internet first came about, it was like, okay, put the magazines on the internet. It's like, well, actually, there's probably a lot more and novel things we could be doing with it. And so I certainly fell into that trap. I'm thinking, okay, what can we do with movies? What can we do with video? But you're right. Like maybe there's something completely different, completely new that we haven't even thought of yet. And that's super exciting. I want to talk about the capabilities for a moment. So Genie 2 to Genie 3 was a pretty big leap. And correct these numbers. I have them written down. So Genie 3, 24 frames per second, 720p, consistency for a few minutes. What hardware, latency, budget, batching tricks made that possible, whether kind of independently in Genie 3 or as compared to Genie 2?
So a lot of, I think overall what we try to do with Genie 3 is to push all of the dimensions of the system to the next level. So I try to think about you can think about the resolution, the memory, and along all of and how many actions you can do every second, right? So we have a few actions that you can so all of those dimensions, if you multiply them, it's like almost a 100x kind of improvement, and this is this is in a way one way to think about the sleep, right? So like to quantify it a little bit, and I think a very key element in our research was to try and balance in one way the quality and the latency. This is something that we worked on a lot because low latency is a challenge, right? As you said, there are hardware. We are meeting hardware limits that we have to work with, and we really leverage a lot of the kind of best-in-class hardware and kind of like architectures that Google has across the different models, and we invest a lot in trying. Like this is even building on multiple years of learning what makes models more efficient. So I without going into all of these details, I can just say that this allowed leveraging all of this work that happens across different modalities really made a difference in terms of the efficiency of the system.
Okay. And then by the way, I saw there's a demo that you guys released, and it was of a jet ski at night on this, I don't know, a huge river. And you see this jet ski bumping into things, and the physics look incredible. I remember pointing out in one of my videos where I covered Genie 3, the jet ski was going past one of the lights, and the lights clearly moved out of the way as the jet ski was going past it. And it was such a minor thing, but it just made the entire video and world look so real. When you first saw things like that, what did you think? What was your initial reaction?
Probably similar to yours. I think we obviously set these goals for ourselves that were pretty ambitious, right? Coming after Genie 2 and VO2 at the beginning of the year. Shlomi obviously was co-leading VO2 and myself on Genie 2. And we were talking about what we thought was possible. We kind of had this sense that a model like this would be achievable, but it's still it was quite a surprising thing when you actually end up achieving it, right? Because obviously during the project you have many ups and downs, right? Research is not a straight line. So you get to the end and you're you're happy, it's looking pretty good, right? And then suddenly you keep seeing these new things and you're like, oh, actually this is really good. And some of the things you see, because obviously other people can play with it too, right? And you almost kind of forget it's your own work sometimes because you see someone create something for me, the painting one was one of those.
Yeah.
Where I just found it really hard to believe that the model did it. I was like, really? Because obviously we're going for quite a general thing, right? We're really seeing it as a new kind of foundation model rather than targeting one application. So it has a lot of abilities that are, we overly use this word emergent, but it has a lot of abilities that we didn't directly train for that it's pretty amazing that it can do, right? So I think we were almost every day there was a couple of weeks where someone did something really cool with it that we didn't know it could do. There's a bunch of others as well, but we could talk about those maybe later.
Sure. Okay, you mentioned VO3. Nano Banana came out just about a week ago. How much of the research efforts for VO3 and potentially Nano Banana intersected with what you were doing with Genie 3? Is it like some parts of it are incorporated into it? Was it just you kind of took learnings from it? And like, yeah, how do you think about those different research tracks coming together?
Yeah, so the story, it goes back a little bit to the story of, how Jack and I kind of started working together. So I was mostly coming from Conveo and Jack from the, really awesome line of work for Genie. And at some point, we just realized that, we like that it's just it could go very far if we kind of like combine the learnings that we have across the board. And the teams, obviously, we're not very far physically and in organizationally, and we thought it's really something that we can try and combine and try to push to the next level. So in a way, I think there are a lot of similarities between video generation and word simulation. There are also some differences. In a way, it was challenging to try and understand what should be similar, what should be different, what we should try and explore different approaches that we used for Veo, for example, and yeah, so definitely there are similarities. Specifically, you mentioned the Nano Banana, and, which I feel like the team is just a trick to get us say this ridiculous name, right? But yeah, it did catch up. So there are definitely a lot of similarities at the fundamental levels, but it's a different product after all. But I think what unifies all of those, maybe systems or models, is the ability to just take something that is very sparse, like some text from the kind of like the user, and build something that is so elaborate and creative. And if it's an image, if it's a video, if it's a world that you can walk around, all of those things are really very creative. And in a way, to me, it's every time I see it, I'm pretty much amazed. Sometimes, like as Jackson, like I'm like forgetting that, forget all of the work that we've put into it and just kind of like surprised by it, because there is something very surprising about the fact that the system, like a model, is able to generate something that is so spectacular that any other way to generate that would require so much work, right? I used to work on 3D engines, as I mentioned, and it's so much work just to get the lens flare to look realistic, right? And now it just works, right? That's mind-blowing to me, right? So, yeah.
Yeah. And I want to talk about Google's custom hardware with the TPU. How integral was having custom silicon like the TPU to the training and the actual inference running Genie 3?
So I think I mentioned before, and every, all of the models that we develop are basically running ultimately on Google's TPUs. And I think having this good synchronization and alignment between the hardware and the software gave Google like a really good advantage, and we're basically able to optimize across the stack. So that's the very good, and I think it also translates to the ability to ship models fast, but also make this hardware available to others, and potentially allowing them to build their models to run on TPUs. So yeah, I think GPUs and TPUs ultimately try to do the same thing. I think that if there are a lot of, I won't go into all of the technical differences, but definitely having our own hardware and the teams that build it, and that's something that opens a lot of optimizations directions.
And as you're training this model, like if you're training a text-based model, you have certain benchmarks that you can compare it against. But like with a world model, what kind of benchmarks would you be testing against? How do you know during the training process if things are working well, if the product is baking and it's going to come out how you think it is? And then finally, when it is actually delivered, what kind of tests are you running? Is it all just vibe testing?
Yeah, I think it's probably, as you would imagine, it's really a mixture of many things. I I think it's not just the comparison of text versus world model. It's probably also comparison of an established field where there are just existing benchmarks versus something that's kind of new, right? So it's not necessarily obvious what you should expect um, when you're doing something completely new. Obviously, we worked very hard on trying to get some like quantitative things we can trust, and I think we've have some pretty good ideas here, and like we've been able to use some stuff, but ultimately different capabilities of the model will require different metrics, and so um, you really have to like all as a group be sort of discussing the pros and cons of some things, and like looking at like you can't necessarily have one. There's not like one leaderboard you can necessarily climb as easily as you can with, I don't know, like a chess elo or something like that. You know,
Right.
It's definitely a complicated picture, but I think in the end we managed to make sense of it. So um,
It also really depends on how we use it. I think the more the more early the research is, and in this case, as it suggests that we're not trying to necessarily improve an existing capability, but we also added new capabilities. So for these, we had some internal benchmarks, but we definitely, it doesn't mean that those are um, the best that's possible, or like some gold standard, right? So unlike maybe I think even for, but I would say that even for text models, right, LLMs and video models, image models, it takes quite a lot of time. It took quite a lot of time for you just recently video models became maybe first class citizens in all of in LML arena, for example, right? It takes a lot of time because there is no it boils down to human preference. All of these models eventually, yeah, you can measure on some task, but people care about how they use it. And I think because it's still early in the war, in the kind of in for world simulators to be interfacing with users, and though it's a bit hard for us to define the metrics. So we'll do it probably as we go, and as more people can use it, we will have better understanding of how they're going to use it, and we'll be able to create metrics that will be more useful to guide further development.
Okay. Can you envision, even if it's not possible today, a more kind of direct benchmark that isn't just based on user preference?
I think predicting the future is a good one, right? Like in a way, predicting the future a few seconds into the future, right? This is a bit of a typical benchmark, right? But if you can predict the future of like given, so that's something that we can also use for video models, right? If you can,
Wait, you have to break that down a little bit. Predicting the future. Please explain what you mean by that.
Sure, of course. So when I think about predicting the future, I'm not thinking about predicting the stock market tomorrow, although that's going to be useful. Maybe we'll get there. But predicting, maybe imagine that you have a ball on the floor and somebody is kicking it. Right now, you can just stop this second and just let the model guess what's going to happen next, right? So as a person, you can imagine that the ball is probably, depending on the angle of the kick, maybe you can imagine where it's going to go and land. And a good model that can simulate an environment will probably be able to predict the trajectory, right? And this can be it can be just a video that you're taking in the real world, and you can actually compare what happens next. So those benchmarks exist, and they're useful for basically understanding how well the model is able to predict the next set of frames, right? So that's one way to consider it, but it doesn't cover a very important aspect of Ford's models, is that it doesn't get the input from the user or agent, right? So if you want to walk around or interact with, it's like that's where we are hitting usually challenges in evaluation, because there is no obvious way to evaluate it.
I guess another interesting angle, which we've been talking about a little bit, is like obviously we designed the environment to be useful for training and evaluating agents, but then we can use the agents to evaluate the environments too, right? So can the agents achieve goals in the world, right? If they can, then maybe the worlds are sufficiently consistent to like enable that. That means that must be a good thing. You can also say to the agents things like, pick up a feather and drop it on the floor, and does it kind of like float down? You can say, like throw the ball. You can say put Mentos in Coca-Cola and see what happens. Like, and you can maybe then say like, if you had an intelligent agent, you could even ask it like, did the world behave how you thought it would, or something like that. So I think this really like sort of two-way thing of like agent environment being a duality and like, both kind of depending on each other and evaluating each other, I think is something that could be really powerful. And it kind of, and at a meta level, goes back to your previous kind of questions. Like, does it benefit you from having these other teams like Nano Banana? Does it benefit you from having TPUs? Does it benefit from you having agents to evaluate? I think that's the really cool thing about building a model like this at GDM, is without being too much of a of a Kool-Aid person, but like having all these amazing teams with other things that can integrate with the model. Like clearly we benefit from all of this. So I think it's pretty exciting.
Yeah. And okay, Shlomi, I have to go back to the predicting a few seconds ahead. I'm sure
Okay.
you've had this conversation internally, right? Immediately when I hear that, I think, okay, let's talk simulation theory.
Yeah.
Like it just, if a world model can sufficiently predict the future, like isn't that proof of simulation theory at that point?
So okay, it depends how deep you want to go, but predicting the
Let's go
obviously
deep.
the future.
Yeah.
I think the future given is not that. I think we know that the future is not necessarily deterministic, right? Based on our understanding of physics. So not necessarily there is a single trajectory, but at the macro level, if you have sufficient understanding and knowledge of like the trajectory of the ball, right? So kind of like Newtonian mechanics can give you the right, like if you know everything, if you know the mass, etc., you can actually predict. So I think it depends on the phenomena, right? And the time horizon. Already today there are simulators that simulate physical environments, and that's if you play a game, you typically games have some kind of a physics engine that just computes some the force and maybe velocity and gets you some prediction. So I don't think the term of predicting like some physical phenomena necessarily is very powerful on its own. I think that the power of word simulators that are maybe learned is that they're very diverse, so you can do things that go much beyond the specific formula, such as a ball going in one direction or the other. It can be, I think, for example, fluid simulation is something that is often being mentioned as a very complex phenomena. There are equations, Navier-Stokes, that kind of like govern the behavior of fluids, and we can see that sometimes the models, video models, and Genie are able to simulate fluids in a very sophisticated and realistic way. Like I think we have this kind of like ocean, kind of like someone got walking around next to the beach in some kind of a hurricane. I think one of the samples that we have, and that's just, it looks very realistic, right? So if you want to create a simulator for that, it's going to be pretty hard. So I think what's exciting is that if we have simulators that can do that and learn to simulate physical phenomena, for example, such as fluid dynamics, without doing any explicit calculations. We don't teach the model. I don't know enough physics, so I can't, even if I want, I can teach the model today, right? So this is something that it's in a way, I don't think it necessarily leads to any conclusions such as simulation theory or anything, but it just means that it is possible to simulate some aspects of the reality at some fidelity with maybe less compute than we would have thought before. Whether we live in a simulation or not, I'm happy to say what I think, but just like it's a bit of a different question.
I would like to know what you think.
So every time I get asked this question, I'm making it more elaborate and far-fetched. So let's see. But my current thinking is, first, I don't think we can know, because in a way, I think there is no actual way to answer this question for us, even if we do live in a simulation. But I think one interesting thing is that physicists who test our reality and run experiments, they observe some limits of like, quantum mechanics. And if those are being able, like if there is some machine that is able to simulate all of that, I think there is a question of how much compute is needed to actually being able to simulate that. And I think this is like, if you apply it in some, like, I think that's actually in a way counter the argument, right? Like, because you need a very elaborate machine to make all of those simulations, and then the next level of reality also requires that. So I basically believe that we do not live in a simulation.
Yeah, it's interesting though, because as you're describing what Genie 3 is capable of, simulating fluid dynamics, for example, it's not actually calculating atom by atom. It's calculating enough to render something that is believable by the viewer. And so maybe it doesn't require such a monstrous machine to actually do those calculations.
But you can still, I think this is the point, that you can still run an experiment. So if you take the simulation, you actually try and you walk, like you will hit in a way the limits of the simulation, right? And I think, and it's not that hard to see, like that's my point. Like I think while maybe we can take video models as an example. They're very realistic. Like when we see, like some of the videos are just like, I worked on VO3, and sometimes like you asked what we think about the outputs of Genie. So Genie and VO, like sometimes I'm like, I can't believe this is generated. Like sometimes you're truly mind blowing. And I think the key is that it's still, even though it looks very realistic, you can still pretty easily prompt it in ways that will break, right? Like even the best models in the world at the moment can still break in some settings. And I think that's just the fact. And it does highlight that our simulations are still limited. There is a question how far we can push it, and if at some point it will actually be as realistic as our experiences. Yeah, I have no answer for that. We went pretty far on the.
I know. I'm gonna bring it back to Genie, I promise. But I just want to close. Jack, I want to get your thoughts. Are we in a simulation? Do you think it's possible, or just a hard no against it?
I thought I'd avoided this one.
I took it usually.
You always take this one. I actually don't have a strong answer. I'm probably gonna say no, exclusively because I just feel like there's far too much going on and it's consistent. It's so consistent everywhere. I feel like there would be at least one glitch somewhere, and maybe you can identify some things that would have been that. But like having worked on these models, like they're really good, right? But like to get the complexity of the real world and have had pretty much zero things that like look obviously go slightly wrong. I'm like, everyone makes a little mistake, so that's my only real thing I can see that disproves it. But ultimately, I think Shlomo made the point before that we wouldn't really know, right? So it's
maybe the mistake is like a deja vu from The Matrix, right? If you remember that scene, like that was the mistake in the simulation.
Exactly, though. So like even in the most compelling movie about living in a simulation, there are some glitches, right? So I'm like, where, and I haven't spent a great deal of time like researching times when people have been like had conspiracy theories about glitches in the world. Maybe there are some, and like no one paid attention, but like I'm not aware of any. So
okay. All right. I promise we'll get off the simulation topic now. It's hard. Once I start thinking about it, I want to talk about it more.
No, but we do have the joke that the next version of Genie will be developed in the simulation. So we
Perfect. Yeah, Genie will develop and infinitely on from there. Okay. One of the most impressive things that I hadn't even thought of when Genie 3 launched and I saw it was the ability to have promptable world events during inference. Is that correct? Is it during inference? Yeah. How does that work? What does the actual user interface look like during that exchange? Because obviously from the outside, all we got was the demos. But like, what does it actually look like interface wise? And then what did it take to accomplish promptable world events during inference?
Yeah, so I think there's kind of two things here. So in terms of the user interface, we didn't really have one, right? So like Genie 3 is not like at this point a product, right? So it's still sort of a research preview. So in this case, like the actual way that the text gets sent to the model for those things, like it wasn't like there was some shiny widget or something like that, or someone speaking into it or anything. It was more just like someone sent the commands to the to the model via like my researcher works on that. But in terms of the mechanics of it, it really is just like sort of the model's just receiving a text prompt like during the generation. So the frames before that prompt haven't seen it, and the frames after have, right? So
So interesting.
essentially the model, it's each frame is conditioned on an action, but then sometimes it will be have the text. So essentially then it has this like causal nature, right? So like the event happens, and then from that point onwards it can impact the world, right?
So if we think about this as an analogy to text generation, it would be almost as if you can insert new text during each token that's being generated.
Yeah, exactly. In a way, think of it like if a text generation model tries to predict the next token, right? So Genie is trying to predict the next frame based on a sequence of inputs, and here we are just allowing the user to say, okay, that's what's going to happen next. It doesn't say exactly when, so the model can interpret it in some way. And it's a very interesting, if you think about it, like it's very interesting because it doesn't say exactly how something should be materialized in the world, and it's it's actually quite an open, like the model can decide. For example, if you ask it, okay, a camel comes into the view, right, or something like that, then are you going to see it when you look to the left, or are you just going to materialize? Like there is a bit of like it's underspecified. So I think this is part of the challenge, is to figure out the right, and that's why when you mentioned evals or ways to evaluate models, benchmarks, I think we're still trying to figure out the interfaces even, right? Like how what goes in, what goes out to the model, and this is one idea that we had that we really wanted to explore, and I think we have some other ideas how you can interact with this world, right? It's not obvious. Text, like when you walk around, you don't just like we interact physically with the world. So I think text is in a way a proxy for that, and yeah.
And so let's say you have this initial prompt and it generates the world, and then during the generation of the world you give it a conflicting prompt. Let's say it's a simple example. In the original prompt, ball is red. In the subsequent kind of in generation prompt, you say ball is blue. How does the model handle those conflicting instructions?
My guess is that the model would try and make it happen, right? So we didn't try that exact kind of thing where like events change what was in the world already. We tried more things that were like adding to the world, like a dragon appearing, or like the person in the chicken costume, for instance. But if you said now the river turns like red or blue, I think it was already a bit brown. It was in London. If you said it turns crystal clear like the Caribbean, that'd be nice. I think it would just do that, right? Like it would just do it would follow the text that it's given. Now, there's another cool example where obviously the model takes text as the world description, but actually you can also prompt it with a video as well, right? So you prompt it with frames. And there was an example that we posted on social media where someone on the team gave it some frames of like one world, and then actually prompted with text that was not consistent with that. And so we have evidence that what model does is try to make it work, right? So it just like in the most natural way possible, it kind of blends these two worlds together, right? So you get examples like the one where I think it's in a room watching people playing actually with the Genie model.
I remember that, yeah.
and then the prompt is about like a jungle with dinosaurs and something like that. And then you turn around and you're in the jungle, but then you look back and you see the room. So the model just kind of makes the text work in the world. And that's, I think, kind of what Shlomi was getting to before, is that like you don't tell it, oh, by the way, your video frames may show a room, but blend it this way. It just kind of does it and makes it work. And like that's kind of the exciting, magical part in a sense, because it's sort of like creating something that you didn't really know what it was going to do exactly. Like even the one where it's like the dragon lands in the canal and like the way it just kind of plonks down and splashes the water everywhere. I think it's like when it actually happens, you kind of all just like, "Well, that's really cool." I didn't know what it was going to do, but that's really cool. So I think, yeah, I think you're right to highlight that feature as like probably one of the most open-ended, exciting parts of it.
And so for what you can share, what does the underlying training data look like? What format is it? Meaning, is it just all video game simulations? Is it movies? Like kind of broad strokes for what you can share. What does the training look like? What does that training data look like?
Yeah, so we train on mostly on publicly available video data sets, and that's pretty much what we can share at this point. But the model, I think the interesting thing is that the model is able to really learn from very diverse video models about the world. I think this is something that's a little, maybe again a little similar to how LLMs learn from just web, text on the web potentially or other sources to predict the next token, and from that it can infer a lot about how the world works, how people express themselves, and how even how to think and how to solve problems. And I think in a way what we're saying is that learning from kind of like those sources of video data also allows the model to learn like representations that are very useful potentially for creating these interactive environments, right? So I think this is a very surprising kind of like result.
There are a lot of people who say that text generation models aren't necessarily generalizing that far outside of their data set. Do you think that video or text to world models can generalize more effectively than text models?
That's a really cool research question, to be honest. I think it's quite hard to quantify that one. But like intuitively, so I'm not actually a super expert on language models, so I probably don't want to talk too much about what they can't do or can do. But in our space, like, I think it's certainly the case that a lot of things that the model can do already are things that I don't think it's seen before. I think it's generally a new thing that it's creating, like the dragon in the canal, or even the origami lizard. I think is a pretty new idea. And then, like, there was the one with the skiing, and the deer, and like I don't think these things have really existed before. And then I can say this a bit more like objectively because I mean I wasn't part of the VO3 team, and obviously Shlomi was one of the leads of the project. Like some of the things VO can do are absolutely incredible, right? So I think there's many things there that like did not exist, like all of the vlog videos, right, of like different animals that I don't think can speak English talking about stuff, and it's really amazing. And like that's what makes them so magical, is that you can create completely new things, right? Whereas I'm not so convinced that like maybe other kinds of models, it's about creating new things. It's more about doing things that we already want pretty well. So I think that's maybe the like more creative element that comes from these models, is from the fact they can generalize.
It kind of reminds me, I had a debate, I think it was a few years ago, when LLMs were still just beginning to get traction. Then there was this argument that maybe, okay, they're just predicting the next token, they don't really learn anything new, and just kind of like repeating the training data. I think ultimately the test is whether it's useful, right? We can debate how much, some like maybe it's repeating the training data, maybe not, and we can try and come up with some tests that are outside of the training data, which is obviously very difficult the larger the training data is. But ultimately, if a model is useful, I think that's to me the bar, right? And I think for video models, we see that they are useful. Like people are creating things that they couldn't have done before. So I hope that with world simulation models and like Genie, we will also see like people just using it and researchers using it for useful stuff. And I think that will be a success for me.
Another thing that's been kind of trending in text generation models is using synthetic data. So generating data with one model, using it to train another, and potentially like debate on whether that can actually scale up to more capable models. Do you see Genie 3 generating worlds to train Genie 4?
That's a great question again. I think So I think there's a different angle to this. Obviously, we're very focused on using Genie 3 to generate synthetic data for agents, right? And so I think that in some sense, the initial design of it was actually ahead of its time. It was always about synthetic data generation for training other AI models. Now, indirectly, if you combine that with what I said before, and those AI models then are used to evaluate future versions of the Genie models, then indirectly that has contributed. In terms of the specific method of like Genie 3 to Genie 4 data generation, I'm not sure. Can really speculate on that one too much at this point.
Okay. And then I have to ask, so Genie 3 limited research preview, small cohort of people are getting it. What are the specific milestones that would unlock broader access or an API to specifically people like me? And me in particular, actually, I want to use it.
So we definitely want to bring it to more people, right? Like it's not while it's a research preview, it's definitely something that we're exploring. We don't have a concrete timeline at the moment. Of course, once we know, we will share it. But it's definitely, the goal is not to build something that cannot be used, right? That like we were built, like I think now a general theme for us is that we want to build things that people can ultimately use and make and build on top of.
Okay, but without speaking about specific dates or timelines, are there specific milestones or achievements internally that you'd like to see, whether it's safety, scalability, that would lean more towards general availability?
I think definitely we need to get some feedback. That's why we started with a smaller cohort. And I think generally when there is a new application or a new kind of like a set of capabilities, we first want to test and hear from people in, as you said, smaller cohorts, and potentially diverse cohorts as much as we can, to hear what they think, what are the risks, what are the potential applications. And I think that's pretty much the main part of it, just to get this feedback and to be able to process it before we expand.
All right. Jack, Shlomi, I want to thank you so much for chatting with me today. This has been a pleasure, especially talking about simulation theory with you.
Yeah, it left me pondering. Yeah.
Thanks for your time.
Thank
you,
Matthew.
guys.